Hey guys, I'm Kelsey, and I'm going to be breaking down the life cycle of a star, particularly one the size of our sun. Before our sun existed, it started in a nebula, which is a large cloud of gas and dust. This cloud was mostly made of hydrogen, and very slowly gravity would start to affect this cloud. Gravity would pull these particles together, causing them to clump. As they condensed and grew, the gravitational force would increase. After so much condensing and squeezing together, it would collapse and create friction, which generated heat. This heat helps develop what's called a protostar. This is essentially a baby star. Over millions of years, the intense pressure and heat in the core squeeze hydrogen atoms together, forming helium. This process is called nuclear fusion. This fusion releases energy, heating the star further and preventing it from collapsing. We're now in the main sequence phase, the most stable phase. In this phase, the star stays stable, like I said, and it's the longest phase, lasting millions or billions of years. In this phase, though, the star's brightness, size, and even temperatures will slowly waver and change. Take our sun, for example. It's about halfway through this phase, which means that it could have been bigger or brighter, or even hotter than we know now. After millions or billions of years, though, stars can't fuse hydrogen forever. As the fuel gets used up, the fusion slows. The star starts to lose the battle to gravity, and the core begins to collapse, puffing up like a pufferfish. Now we're at the beginning of the end, the death. As stars use their fuel, they eventually run out of hydrogen, one of the key elements of the nuclear fusion process. The energy that was created begins to cause an increase in pressure, the same pressure that originally balanced the gravity's tendency to pull the matter inside of it together. The core collapses. While collapsing, the core faces an increase of temperature and pressure. This is now a red giant star. As helium fuses with carbon, the outer layers of it expand exponentially. Over time, it pulses and sheds its layers, like an onion almost, which creates a planetary nebula. The outer layers are gone, but the core is still there. It was left behind and turned into the last stage, a white dwarf. It's about the size of Earth, taking billions of years to cool before fading into the surrounding darkness of the unknown. Every star has an ending, but our star will go out without a bang, fading silently.